How to use the virtual oscilloscope in TINACloud. Virtual oscilloscope in TINACloud. Now let's learn to operate the simulated virtual oscilloscope. In practice, we very often use an oscilloscope to measure, analyze, and debug circuits in the time domain. So it seems obvious that a simulated oscilloscope can be used in circuit simulation as well. However, there are a few important things you must know about. Even if you analyze the circuits in a computer with a simulated oscilloscope, it is still simulation. You should not consider it as measurement unless you use real-time data acquisition for obtaining the data. The simulated oscilloscope is very useful when you want to adjust some component values of small circuits and want to see the effect of the changes immediately in order to fine-tune your circuit. For large and complex circuits, the simulation may take longer, minutes and even hours. In such cases, it is inconvenient to use the oscilloscope controls, as unlike in the case of real measurements, you cannot see the waveform and the effect of the changes immediately. In these cases, it is better to use the transient analysis from the analysis menu of TINACloud, which creates a diagram when the simulation is finished. Load the circuit colpits.tsc from the examples folder of TINACloud. The transient diagram is already inserted into the circuit. Delete it before simulation. To delete the diagram, first click the diagram and then click the red X delete icon on the toolbar, or press the delete key on the keyboard. Delete the additional text in the same way. Note that the program automatically saves the changes into this file while you are editing. Now let's analyze our Colpitts oscillator circuit with the simulated oscilloscope of TINACloud. Invoke the oscilloscope from the TNM menu. Press the Run button. The Out1 signal appears. Use the controls to make the curve bigger and more detailed. By default, the oscilloscope is in the auto, i.e. free running mode. To get a steady state image, you should enable triggering as follows. Set the trigger mode to normal. Set the trigger source to Out1. Set the trigger level to 300 millivolts. Consequently, the waveform is stabilized. With the controls of the oscilloscope, you can make a lot of changes on the displayed waveform. Here are a few. By default, on the oscilloscope's rising edge, triggering is used. So the display starts when the signal rises above the trigger level. You can also set this to falling edge triggering, where the display starts when the signal falls below the trigger level. You can also bring in the Vout signal by selecting Vout under Channel. Let's have the same vertical settings for Vout as for Out1. Finally, you can export the display into a diagram by pressing the Export to Diagram button under Data. Note, make sure the oscilloscope is not running. For small circuits, you can also use the simulated oscilloscope to fine-tune your circuits. For example, you must have observed that in our oscillator, while the out1 signal is sinusoidal, the Vout signal is quite distorted. Let's fine-tune the circuit by changing the R resistor so that both out1 and Vout are sinusoidal. Double-click the resistor R on the schematic. Now you can change the value of the resistor with the up and down arrows at the right-hand side of the dialog box and watch the waveforms on the oscilloscope. You can also set the step size. Change it to 500 ohms. Raise the resistance to 5K in 500 ohms steps until both signals become sinusoidal.
תהנו משימוש ב-TINACloud. להזמנות רישיון ותמיכה טכנית התקשרו 03-649-1202 www.tinacloud.com